Our lesson for today is on thermal energy, heat, and the direction of heat flow. We did this simulation on the states of matter. And if you click on states, you will see this. This is the default. The default of the simulation is showing neon molecules. So if you switch out the thermometer, here's the thermometer, switch it out to C, you will see that this is the temperature for solid neon, which is very cold. It's a negative number. If it's a negative number, it's very cold. And then you can also switch out it from being solid. So this is solid. That's the model of solid neon. And then here's liquid. And you can see that the particles are moving faster and that the temperature went up. And then if you click on gas, you can see that the gas particles are now moving a lot faster, right? So there's liquid, there's solid. You can see that as the states change from solid, liquid to gas, the particles move faster. And also from solid, liquid to gas, you can see that the temperature is getting warmer, right? Even though it's a negative number, the negative number is decreasing. It's going closer to zero. That means it's getting warmer. All right, so now we're going to create a pictorial input chart. And the pictorial input chart looks like this. All right, so this should be in your notes, your learning log. You should start processing thermal energy, heat direction, heat or direction of heat flow. And the do now for today, you were supposed to research what is the difference between thermal energy and heat, and what is the direction of energy transfer. So you should have learned that thermal energy is the total kinetic energy of an object, right? So we've been learning that all of these particles, so let's go back to the simulation, all of the particles are always moving, right? But if you get the total and moving, the motion of an object is called kinetic energy. Particles are always moving, so that means that they always have kinetic energy. And now it all depends if they move fast or if they move slower. But if you get all of the particles of an object, that's the total kinetic energy, and that is called thermal energy. And thermal energy you can actually measure using a thermometer. The thermometer measures the average motion of all the particles of an object. That's what the thermometer is for. Now heat is the transfer of that thermal energy from one object to the other. So heat in itself needs two objects. Thermal energy transfer is called heat. The direction of heat is always from warm to cool. So if you have like hot cocoa and then you drink it, you can feel the warmth of the cocoa on your tongue or on your lips. And the reason for that is because the thermal energy of the liquid is now being transferred to your lips or your tongue. And there's a difference in temperature. There's a difference between the thermal energy between the liquid and your tongue. So the transfer is from warm to cool. Same thing if you are holding on to ice. You would know that the ice melts in your hand because the thermal energy from your hand, which is warmer than the ice, is now being transferred to the ice. All right. So that is the direction of heat. The direction of heat flow is always from warm to cool. If there's no heat source, it's always from warm to cool. So looking at our pictorial input chart, we have created the model from the simulation. You've got solid and liquid and gas, and we just used neon particles. We placed the thermometers in each container, and we labeled it solid, liquid, and gas. And we also colored where the thermometer would show. And this is just to show, this is not accurate, but this is just to show that gas has the highest temperature than liquid and solid has the lowest temperature. So this arrow shows that from gas to solid, particles move slower. From gas to solid, kinetic energy decreases, and from gas to solid, temperature decreases as well, right? And that is your pictorial input chart, also called a PIC, on thermal energy, heat, and the direction of heat flow.